In the previous video, we talked about the reasons for and benefits of automated unit testing. In this video, we're going to look at Python's standard unit test package. We'll talk about how to structure a test file, how to write tests, and draw a comparison between what happens and what should happen in these tests. Let's jump straight in. The unit test module contains a framework for performing automated unit testing. Most of that functionality is based around the unittest.testCase class, which we will inherit from to create our own tests. In this example here, we see the basic features of a test case in action, test methods, and assert methods. Any methods we define a class inheriting from test case that have names starting with the word test are assumed to be unit tests. In this example, that means that the test addition method is a unit test, but if we had added another method to the class called connect, the unit test module would not treat it as a unit test. A test case class can contain more than one unit test and should, when those tests are logically related and require the same operating environment to run. Inside our test addition method, which is a unit test, we used a method called assert equal to actually check that the result of the code was as expected. Test case provides a wide range of these assert methods, which test for various relationships between our results and what we expected. We've already seen the assert equal method. It checks whether two values are equal and makes the test fail if they are not. The assert not equal method performs the inverse operation, checking whether two values are equal and making the test fail if they are. The assert almost equal and assert not almost equal methods are for use with floating point numbers. The way computers handle floating point numbers means that numbers, which should be exactly equal, actually differ in their least significant bits. For example, if we square the square root of 7, the result is not exactly 7. So, assert equal will treat it as not equal. However, assert almost equal will recognize that the two numbers are the same for practical purposes. The assert greater equal, assert less, and assert less equal methods check for ordering relationships between their arguments. The assert is and assert is not methods check whether their arguments are references to the exact same object. The assert is none and assert is not none methods are a special case of that, and check whether their single argument is in fact none. The assert is instance and assert not is instant methods check whether the object in their first argument is an instance of the type in their second argument. The assert in and assert not in check whether the object in their first argument is a member of the container in their second argument. The assert count equal method is interesting. If we want to check whether two sequences are the same, we could just use assert equal, but assert count equal is for when we want to check whether two sequences contain the same values but don't care about the order. The method will cause a test to fail if any of the members of either sequence appears in the other sequence a different number of times. So, if A is in the first sequence twice, it has to be in the second sequence twice as well. But we don't care where. Finally, we have assert raises, which functions a little differently because it needs to catch the exception raised by running some code. That's a situation tailor-made for a context manager, and that's what assert raises is. Used in a with statement, assert raises makes the test fail if the code inside the with block does not raise the expected exception. That could seem a little backwards, but it's correct. The test fails if the expected exception is not raised. Sometimes, raising an exception is the correct behavior. For example, passing none into the int constructor should raise a type error, and if it doesn't, that's a bug. I mentioned in passing that all of the unit tests in a test case class should share the same operating environment. What does that mean? That means that each of them expects an any external data that they access to be in the same state. For example, each of the tests accesses a particular file, and each of them expects to find the same information inside that file. In this example, we have two tests that both read and write in the same text file. Both of them expect it to contain the same specific information when they start running. In other words, both of them have the same expectations about their operating environment. When we have multiple tests that share the same expectations and they're logically related, we should group them into a single test case class. We give that class a setup method which is responsible. Then, we give that class a setup method which is responsible for making sure those shared expectations are met, and possibly a teardown method which cleans up any changes that setup or the tests left laying around. The name of the class itself doesn't matter. Simply inheriting from test case is sufficient to identify them. The setup method is run before each unit test in the test case. So in our example here, which has 2 unit tests, setup is run twice. Similarly, teardown runs after each unit test. That way, the changes that one test might make to the operating environment are removed before the next test runs. The starting environment is the same for each unit test in the test case. So that's the basic mechanics of Python's unit test framework. As far as writing test goes, to run the test, we just need to invoke the unit test package from the command line. We tell it the file name of the module we want it to run tests from, and it finds the test case classes in that module. Module creates instances of them, runs all their tests, and gives us a report on which tests passed and which failed. So in this video, we've seen how to write basic unit tests and run them. There are even easier ways to run the test, but we'll look at that after we examine mock objects, which is the topic of the next video.